I'm Pascal Peduzzi. I'm the director of GRID Geneva, an office of the United Nations Environment Programme. What I will present today is, in this module, is a study that we did in Negril, Jamaica, regarding beach erosion. And more specifically, we identify and quantify the role of ecosystem services for mitigating beach erosion. It was done in the beach of Negril. It's in the west of Jamaica. It's a set of two beaches that together is 30 kilometers wide. The mandate that we received from the Jamaican government was to discover why the beach is eroding, how much it is eroding, what are the future trends, and what can be done to reduce this erosion. Once it used to be a very wide beach, about 40 meters or to 60 meters wide, but through time it's been eroding to the point that it is now affecting the local touristic infrastructures such as bar and restaurants. What is important to know is that in these 10 kilometers of beach, we have 25% of the hotel rooms of Jamaica, which account for about 5 to 6% of the national GDP. So it is very important for the national economy, as well as the very local level. We have local livelihood. About 75% of people depend on local livelihood from this tourist industry, of course relying on the beach. So what we wanted to know was what was these drivers. So the first hypothesis was that it was induced by climate change. So is it sea level rise? Is it storm surge from tropical cyclones? Higher energy of waves? But there is also local induced impact from decline of ecosystems or building on the beach. We were not able to test the building on the beach, but we tested all the other factors. So the study was based on two different tracks. The revamped methodology is using a set of consultations. The consultations are used to identify the ecosystem services, to identify the threats on those ecosystems and potential solutions to reduce the threats of ecosystem services, and also to identify the role of different stakeholders. On the other hand, we have the scientific analysis that we use to evaluate the status of the beach erosion. We identify and quantify the role of ecosystem services in mitigating beach erosion, and we provide a prognostic for future impacts on sea level rise and ecosystem decline. For the consultation, we did that at different level. We used expert consultation at the national level. Then we moved on at the local level to consult with the people, the stakeholders, such as people working in the hotels, in the tourism industry. We will also go to the community level in a place called Whitehall and Little Bay, which are a fisherman villager and a suburban area, to really have the perspective of the local community on why this beach was eroding and what was their understanding of the processes. On the scientific aspect, we use aerial photography from 1968, as well as very high resolution satellite imagery, 65 centimeters resolution from QuickBird, to look at the beach erosion, as well as classifying the ecosystems, such as the mangroves, the seagrass, the coral. And we found out that there was up to 40 meters of beach erosion in 40 years. That's between 0.5 and 1 meter per year. So it was a tremendous erosion. We tested the global factors. We had a lot of data on those factors, but we were limited data on decline of ecosystems. So we had to generate this study. So to look at the decline of ecosystem, we take this satellite imagery. We classify the coastal and marine ecosystems, such as the dense and patchy seagrass, the coral. We measure the width of these ecosystems in front of 72 sites where we had the profile underneath the water, the slope on the beach, and we extracted those parameters to build a table. And then we also looked at the parameters in terms of erosions for those 72 sites. So you see these patterns of large erosion to small erosion. It varies along the coastline, and we wanted to understand why it was different in some places versus in other places. The statistical regression gave us results that the main factors were the decline of ecosystems. So the seagrass was the main factors, and along with slopes and waves, and it corresponds to 47% of the model. So we saw that the seagrass was tremendously important. The coral was even more so important. In fact, 23 times more important than seagrass for blocking the wave energy. So the fact that the coral decline was a major influence for this decline that we see on this beach eroding. This yellow line was the status in 1968. Then it's eroded to the status in 2008. This is the current status. And now with the model, we can erase all the ecosystems artificially in our model, and this red line gives you the possible shoreline if all the ecosystems are removed. So you see it's very close to all the hotel infrastructure. If we move to another place, it's about the same setup. We can place a graph where we can move and play scenario. So what would happen to this red line if we remove all the seagrass, for example? And that gives you the next shoreline beach. And we can also add 1 kilometer of seagrass and see that the beach would recover. So the result of revamp was that climate change was only accountable for 9% of beach erosion. The rest was locally induced by the destructions of coral through lack of sewage, lack of sediment, more sediment into the water, the conversion of the wetland that they call the morass into a cropland, and the daily removal of the seagrass. The people that comes to Negril as a tourist, they don't like to swim into the seagrass. They don't like the seagrass. But the seagrass is essential for the beach. So the beach like the seagrass, and the tourists, they do like the beach. So we have to find a way to reconcile how those ecosystems and the tourism industry can coincide. So we tell to the hotel people, if you want to remove the seagrass and create a pool where people can swim, that's okay, but you have to replant seagrass all around and protect the seagrass otherwise, which is what they did. They also rebuilt a sewage power plant to reduce the sediment into the water. So seagrass and corals are providing several services. They do wave attenuation for shoreline protection. They provide a habitat for the marine biodiversity. They stabilize the sediments. They maintain the water clarity. But if we see all around the island of Jamaica, we have this, if we remove artificially, we see all this ecosystem are like a security belt. There's the seagrass and coral are all around Jamaica and protecting the shore. They maintain biodiversity and they provide protection from storm surge. But they also have aesthetical value, they store carbon, they are good for the tourists because the divers, for example, they go in, they see the coral reef. So they provide all kinds of different services. So it's a multiple option. It's a no-regret option, in fact. It's natural, it's cost-effective. Usually it's very cheap they're easy to and can be done with local population. They require very low, if any, maintenance. They've got aesthetical value, carbon storage, and so on. On the other hand, the grey infrastructures also have advantages. The equations are very well known, so we know how high or how width we need. They don't need to grow. Well, we need to build them, obviously, but then they're directly functional. And you don't need to retrofit the land cover behind. So as opposed to coral, where you need to have a good water quality, so you need to retrofit inland. So, but one thing, sometimes you can't do without the green infrastructures, but in this case, it might be good to do a combination of green and grey engineering, so that you can build on top of the grey engineering, you can regrow coral, seagrass and other ecosystems, so that in the long term, you restore ecosystems. We have several publications that feel free to read through. I will provide the list with this module. And with that, thank you very much for your attention. I hope that this local perspective was useful for this MOOC. Thank you very much.